So the only question is C compatibility, of course, basically not really, except lose bottom in light theme. That built better. You want a light theme? Seriously? Also, why do you can press invert on your composition manager of, then you have like I think most people here want, like, why do they open this in Google Drive? Like why does the standard organization ship this out of Google Drive? That is extremely silly. Like why would you do that? It's like we could parse. I think most people want here a dark theme. Probably downloaded it previously. I mean, also like 2025, they outsource that too. So for compatibility, we don't need blue light. Is that not here? That is bluish, right? I think we have had chosen some light bluish blue light thing. Maybe to, I mean, so we could just write new code. It's is pity that I. So how do we? Yeah, I deleted it. It is what it is. What did I had here? Let op code. And I had here already some things like ld dot, and we can't write it like this in the Lua table. How did I write that? I think like that. And so on. Yeah, that's not why. What did I press now? Why is this here in? Why is this cursor not so strange? Equivalent focusing issues. So we have here end and stuff, or whatever I had here the other day. It's of course a pity that I didn't save it. We had here stuff like end. I mean, yeah, we need each instruction. And we need here more, so probably we want here a table with all the details, how to assemble it. And so if you do this in C, you have similar tables, just you do your struct with all the fields or whatnot. Here we can duck type it. Maybe the first is the encoding, the opcode. Then we could somewhere, not sure if we call this type or just T for type. We even have here, I think those were I for integer, right? They had, oh no, I is immediate. R maybe, R for register. Here, yeah, it's probably R. Okay, that doesn't work, that needs to be string. Unless we make it an R type. So we need your information how to encode it. Basically, that's already most information we need for most instructions. What is the opcode, what is the type, and then the type implies already what other registers and stuff we need. Let's this time save it. We should somehow automatically extract it. And for testing, so either, what did I had here? I probably had, did I had emit R and stuff. I mean, we could insen, I mean, you insen for instruction, you common abbreviations. Okay, my current Lua fork is like that. So basically those, I think I had here already, what did I had here? All right, I had a table, I had here some S for stream table, I had here S. Yeah, pro tip, save it. I probably didn't save it because like I thought like random shit. So the next entry in this table for now, this is just prototype testing. All right, I had here simply, I ended here the stuff together. Basically R needs, what do we need? We need this opcode. Maybe we use a raw number here already. And I think I said, so that is R for function 7, function 3. So I probably shifted. So what we, all right. So we didn't have the most. Do I have shift? Yeah, I have shift like this. So basically the opcode, like basically we need to mask here some bits. And shift it. We should do this once, and then we have a template to copy. And welcome everyone. Basically end that with the mask for that. That's a little bit annoying. Okay, let's do this later. Because we need to fill this mask together. We also have the registers, so we have source. So how do we probably do destination, RS1, RS2, and that's all we need for that. And that's how you write code from scratch, right? Like, the irony is like many people don't write often code from scratch. They just fork other stuff or use frameworks and stuff. So this should then be the raw register numbers. So this will just the pure emit thing. We also need tables with register numbers. Like basically we could have pretty names. Maybe just singular, that when you type it, then the difference between singular and plural in language grammar here is how you use it, right? Like then always you need to type rex dot something to index it. So I would prefer a singular form here. Rex. So this are of course just named our what was I think they were named X for X-lang X0. So basically for this here, it will, for most RISC architectures, it will simply be that. I will need Excel now, LibreOffice complete. The only thing here is mnemonics here of user readable argument register stuff. But we will see. Okay, that's the builds. Actually, did I updated LVM today, I believe. Yeah, I updated this. Yeah, 21.5. First time Z-test build. If we use our, so if you want to see some real-world assembler, do we have some tests? I have here some garbage tests from the other day. So probably don't have this in the history, do I? Build RISC-V. If we test assemble to GCC SO-testc. Yeah. Let's optimize it. And maybe okay, so I guess some parts of the backend it's a green screen. Who said it's a green screen? We need to improve this further. Yeah. Yeah. Yes. We have here some privacy measurements that random internet trolls don't know from where we are streaming for. previous incident reasons. I think it wouldn't be the hardest thing to make. I mean, parsing this attribute stuff is a little bit annoying, but why is this here? Okay, that is interesting. Adverts. So RISC-V privileged architecture provides fields in M-either to control them. We note that newer Spark and MIPS either reasons have deprecated support for running 32-bit code unchanged on 64-bit systems. A related question is why there is a different encoding for 32-bit adds in RVI and addW. addW opcode could be used for 32-bit adds in RV32 instead of the existing design, which uses the same opcode for 32. RVI thinks it would more consistent with the use of the same opcode load. The very first version of the ISA did have a variant of this alternate design, but the RISC-V then was changed to the current choice in January 2011. Our focus was on supporting 32-bit integer in 64-bit ISA, not providing compatibility with the 32-bit ISA, and the motivation was to remove asymmetry that arose from having not all opcodes having a W suffix. In hindsight, this was perhaps not well justified and a consequence of designing both ISA at the same time as opposed to adding one later to sit on top of another. We had full platform requirements into the ISA spec, which would imply that all would have been required. It is too late to change the coding now, but this is also a little practical consequence of okay, so add is always using the register, the full register size. And we have advert RV64I only that define logos to add and sub but operate on 32-bit base and produce signed 32-bit result. Overflows are ignored. Yeah, how to handle, okay, do we have, okay, load. I do have this lowercase. Okay, they have them, okay, here they have them, wait, here they have them, was it not lowercase a second ago? Ah, right, and here it was lowercase. Yeah, in general, I'm not an all caps fan. It's so SQL and somehow it's what did ITX or it's we need to generate this anyway. I mean, speaking of caps, we basically also no need to do that here. So yeah, this bits, so this will be the raw numbers. So that's basically then RS2 shift 20, RS1 shift 15. I mean, we could even add, I mean, what would be probably clever. Define, not replicate this magic number all over, like just define constant thing once. Just Lua doesn't have constants. We need our own language for that. And RD shift 7 and the opcode. So only the opcode is basically we need here shift things, unfortunately. We need to make sure, like if we pass, I would say it's easier to just pass one opcode thing there. It's probably more readable instead of function fields, I would say. if you do this excessively, you might have other performance requirements of potentially not shifting stuff together, but I have doubt that changes much. Because that is 7 bits, we can just 1, 2, 3, 4, 5, 6, 7. Is that not amazing? The only thing now is function 3 has, maybe to make it more readable, we could let fn3 equal, because I mean, yeah, this is not really a performance thing. Why is this, by the way, called 7? Is it like this? Why is this 3? Because, but this is also, is this 7 bits? This is 7 bits. fn7, that is enough for, yeah, that's enough for integer. So either, because we need to mask this stuff to the appropriate mask and shift. Okay, let's type this one. So fn, so that's opcode. Where are we even? Here. So that is 3 bits. So that's now a bit of annoying thing, how to write this. I would say end this with 3 bits. 1, 2, 3, 4. No, what? 7. We need 7. 12, 13, 14, 1, 2, 3, 4, 5, 6, 7. I mean, what you obviously you can write this in nearly infinite. I mean, not nearly infinite ways. If you count all creative things. What I sometimes do in C is shift this down like 7, and yeah, but I think with this, you could also convert this to hex, but I really like this binary location. Like if you have there whatever that would be in hex. I mean, obviously I don't know what is in hex. And we still need to shift this. So I wrote this here in vars, which probably I would recommend to do to have it more readable. Actually, we could. Okay, that's not at the right place. I mean, yeah, maybe we shifted to the right place here already. That is, we are here already, so it's only 7 to 12. So that's 7, 8, 7, 8, 9, 10, 11, 5 bits, right? Does this work? I mean, what we could theoretically do is, I mean, is it more readable? If we shift it after all, because like often I shift it, like, is it more readable to like lose some bits here? Shift it down 12, right? That would match the spec more. End it with this here. Oops, I even had a typo there for a reason, so did I just do that 1, 2, 3, and then shift it? Like, do you all prefer that? What was even my operator yeah, we better don't play tricks. I would argue readability is king even, but that's, and then is that more readable? It doesn't even, is this, what is that? one shift more, right? But it's not performance. I mean, if rule of thumb not micro optimize, this kinder might be more readable than less error prone. I mean, error prone is relatively only code this once and then never look at that again, but given we don't need to, where do we even need this? Oh wait, I did this wrong. You see, so quickly do you do stuff wrong. Who noticed this is only 7 because opcode is 7. Yeah, I think this is more readable. This is how I usually did it in C. Probably for readability reasons. So because then we need 12. I mean, theoretically, the shifts could be optimized away there, right? Which we would need to our compiler to do. Oops. Yeah. So 7 is, then we have 7 plus 5. Oh no, 3. That's 7, right? Like, did I do this correctly? Here's 7, there, and here we have then 10. 7 plus 3. And that are 7 bits that I would hex mask, but for consistency, 1, 2, 3, 4, 5, 6, 7, and then at bit position 25. Is that readable enough? And then for readability reasons, FN7. Wait, did I even look at the right? I think it's R type, right? Do I admit R? I mean, maybe we even lowercase that. So FN7, R is 2, R is 1, FN3, RD. There, I guess that should be usable. So for testing, we could actually implement all instructions. Like basically, if we, yeah, for testing and portability, we need ELF support anyway. So basically, we cannot just dump it out into, we could dump it out in a raw file, but that wouldn't be the most helpful. We also need to implement minimal duck typed ELF support. So how do we use this? Emit, how would this code like? So basically, all right, like basically we could even have emit insen or whatnot. Instruction. I think usually we write it like this, right? So this probably would get like basically the opcode again, with all the other things. And then that could local opcode in from opcode, right? Actually, we could start pre-testing this. Basically like, okay, let's do this in a second. So now we have entry into the opcode table. And then we don't have a switch thing. Yeah, our language obviously needs to be better than Lua. Surprise. If not, So we should share here some common, what do we even have? We should share here some common compiler infrastructure thing, but for now we can simply throw an exception. If not O, then throw how did we want to write that? As okay, here we get a string and index by that name. Opcode and what we should do from the very beginning is have a test suite. Nothing more like pro tip, like do a test suite. That means even for the most simple thing, as soon as it starts to do something, add some hello world test cases for each thing, and then when you develop, always make test. Don't even bother. Basically, if you test you like, and then unlike like GCC, that's also so crazy. Like GCC, so much undefined behavior and bugs and regressions that they have hundreds, thousands of tests where it's normal that always some small percentage fails, right? Absolutely mind-bogglingly crazy. Just need here some. In this case, it means one instance, starting with a couple of instances, or like, or each group instance. Like the first thing can simply be like test all groups of instances, or maybe even all, like all you implement and one for each or whatnot. I mean, theoretically, each register and stuff, but you could also basically, as you know, your code is symmetrical. You could iterate all these instant testings of like x0, x1 and stuff. Did I put XOR? Let's use OR. We don't know. Let's test with OR. 14. That didn't last long. All right, we probably can't, because it's a keyword here, or I think we can work around that. That's type local because I typed local for too long. Attempt to call global emit insen emit. Opcode or not supported actually, I guess. Some quotes could help, huh? Okay, let's see if it does XOR. That's of course not yet. So what we do need to do next is, I guess, unfortunately, I mean, normally Lua doesn't have case things, which is annoying. Oops. Not a fan of ... For our language, you probably use plus. Normally case thing switch, but Lua is our bootstrap language for now. Yeah, I mean, basically GCC is always like GCC is releasing forever with every architecture 0. Like a percent or 0.5%. But yeah, also like maybe you shouldn't, like, if you write a compiler for languages undefined behavior and you optimize the heck out of undefined behaviors, and 0.4% of test suits. Like, who cares about hundreds or thousands of? It's we optimize undefined behavior to perfection. So then we probably, okay, we stick in here the number. From opcode things. So that's the table, so that like the first thing is opcode. And if we maybe, I don't know, would it ever need more metadata? I don't know. We will see. I mean, obviously here all the other types. We could actually prepare those already. Yes, I would also like the syntax is different. That's why we write a new language now. How many more do we have? S and U, R, I, S and U, R, I. Was it sorted already? I, S, and U. There are slightly more elegant ways to do that. But it is, I mean, we could actually, directly store the encoding function here and just, but whatever. We need to check the arguments. We need to convert the arguments. So here we have a string. Okay, let's maybe use lowercase. They have here A and stuff. It's a little bit annoying now. We certainly don't want to dynamically pass this out of string matching. Actually, I think we do it. There, 31 registers. You gotta do what you gotta do. Oops, 62, yes. Oops, I could also have edited this, but over here, oops. It's probably fine. The only reason I do that here is we would have aliases and they don't map directly anyway. So only thing is probably I would, but save you some space, I guess. But that is for another day. Because we need to convert them now. The question is, do we could do that here already. Or in emit does not really matter the most, I would say. So here we would have, maybe we do that here. Obviously one let local convert register whatever. So the one register name, so R, so that would be the only other thing. So we would want some generic error handling. So because we don't have opcode things here anymore, we anyway only have the opcode number. Okay, only having the opcode number is a little bit annoying for maybe we pass down the original opcode. Just so the diagnostics can print the name. So that's of course design decisions, right? Initially thought like, yeah, all we need is a number, but obviously we could also pass down both. So op was origin opcode. Maybe we pass even down the table, we will see. But like this, we also need to. So we know the opcode exists. So maybe we call it O then. Also, I mean, it probably still is readable enough to differentiate from 0. Rust, will it build? I better don't take a look there. Let's log out already in case it doesn't build. Suspense to memory when we're not logged in. Save some electrons. Let O equals, so we also need the stream here. Emit insen as opcode. Emit insen. Doesn't matter. Just some random stream here. Later this will be different. Later this will be some elf encoding object thing, but that is for another week. So as XOR and stuff, as opcode and stuff. Basically look up this opcode. Unfortunately, again, I mean, this is okay. Let's pass down the, like, I don't know, maybe for some things we might need special additional metadata. I don't know. Let's just pass it in already. Like basically opcode name, the encoding information. So change this here some more. That here is native Lua. Why is this? This is native Lua var arc support stuff. Which is amazing, right? So much more amazing. Compare that to C-based VArc start and thing copy. This is basically how we should design our new language, like how language should be, like no surprises and not annoyingly cursed shit. So where are we here? So O is a number. Oh wait, oh no, it's O is an object. Okay, we get here quite some confusing. O is the encoding information. Opcode encoding OPC. Yeah, let's use the same names here. What did I do? Oh, opcode encoding, opcode encoding. Unknown opcode encoding type T. Because then we can have better diagnostics, because we need so opcode. So basically let O be opcode encoding 1, then basically we don't need the original name for the encoding, so we can just replace it. So RD equals convert. I mean, we could call it parse convert register RD. I mean, in Lua we could even, this is a fork of Lua currently, basically just to have it readable. RD, RS, R2, RD, RS. The only thing is we probably basically supply our opcode name for diagnostics. We obviously only want this, the diagnostics only once, like this is basically which opcode that needs for information. So that needs to encode that register R. Oh, there's also a typo. So let rec be, oh, this is rec, right? Let's our shadow rec, our internal rec thing rec R. And if not, then actually we could copy that here. If not, then throw maybe we even want to pass in the name. We probably want to pass into context informations for better diagnostics. Opcode, what did we have here? And our name. just so that it can print which one is missing, right? RD, RS1, convert, RD, op RD, RS1, things, yada yada. Okay. Opcode, op, rec. I mean, we will later see how we could also copy the diagnostics from GCC, whatever, like basically register not found. It could even be nil of not supplied. Register R. Actually, I wanted to log that differently. That's actually annoying. This sucks. Don't compose strings like this. Do it like this. Here's a string and then format. We need a object here for this format to work, I believe. I think with in Lua at 5.1 it doesn't work otherwise. So op register. Actually, the only thing does that work in Lua? I always forget. Probably should work. I hope to print nil. I mean, if you write Lua the whole day, you would know. Just I don't write Lua the whole day anymore. Call it Lua. Ah, right, because this is called in our fork. We it's that argument. Oh, this does not work. Okay, we could protect for that. We could. Yeah, that's. I think in our software, we actually in our software we have some special add for Apple like auto type conversion thing. But okay, let's assume for now that that is there. Later we can make this more fancy. Register S, so that is convert rec to also like then we need to return rec. Look up register the rec R. If it didn't look up, then register could even opcode needs whatever the diagnostic. Or simply invalid register. Yeah, much better than concatenation for I'm pretty sure this diagnostic is not amazing. For opcode So invalid register R for opcode op or name. Then expression near, if not, then 70. Was it not? No. What was G? Was it not G? What is go to line in Emacs? GG? Is it different from? Is it different from X-Emacs? If not, then. Ah, yes, this is also like maybe it didn't. Let's say then expected near equals sign. That probably helps. $85. And the file expected near end, I probably don't have enough ends here somewhere. Med R, let things, maybe here somewhere, it's the last thing we did. Here, no, this is actually, throw invalid things. If not, that is a little bit annoying, should not happen too often. Then expected, into file expected near and 85. Yeah, commit early, commit often. Does someone see? Nobody sees. If not, it's a little bit annoying now, but it is what it is. Here, throw else if. Yeah, that is too much. Opcode XOR not supported. Amazing. So we use for testing at or and, or what do I have here? And XOR. Okay, XOR we should have. What did I have there? Opcode if OP, if not OPC, then do 73. If not OPC, OPC opcode. Should this work like this? Wait, it doesn't work like this. I did this wrong. That argument format got nil in argument receive 53. Still not amazing when stuff not segmentation false. If not, then argument 3 our name. What did I even do there? X0 or what? X0. I mean, we could also 1, 2, 3 just of course. Okay, it's still building. So it probably did build Rust. Oh, look at that, it did build Rust. Yeah, A0. So parsing this should be as simple as splitting the string and throwing the arguments then in there, right? Should, famous last. And then watch arrows and stuff. See what syntax error? where I had my syntax error. Basically, but I found it already. So format in 53. 53, if not format, if not R. So we look up R, that is the name that comes down here as like X0. Yeah, I did this correct though. X0 should be there, rec. Let underscore, if not underscore, then invalid. Oh, this also doesn't. Do we do this correct here? Convert rec RD opcode. Maybe we should add here at least. Oops. We probably should have a type safe format thing, project wide thing. Got table spring x got table. This is no, this is should be. Do I pass this in here wrong? Let's see. OP. We also have this string here. That is why this is off by 1 because, yeah, static typing would have caught that. Good that we will in our language support static typing. OP, look at that. Good. We also want to print this then. So basically that will be all 32-bit. So let's test print this here. Test is symbol. So then we obviously there is then much more creating proper ELF file like management structures. But for today, hex dump that for I, O for opcode in our. Oh wait, does it work like? Yeah, it's a table for in I pairs as to. Can tell you, you should have only one language keyboard layout in your office, otherwise you get crazy. So this should all be numbers. So just print them all as, and it should be print, not print line, you all. And it should not be IO, like, oh yeah, IO. Should not be print line, like print line is there. So simply format all as, that should work as O32X, I believe. Opcode. I mean, we could also pre-print an address later anyway. If we symbol near what? Right. I patched our Lua in the meantime. Like yes, I wrote too long Lua. This is a Frankenstein Lua of into the direction of as we are done with Lua. I made our internal language. Do done things here of Paris is of course not Paris. Pairs. No. So wait, this is also wrong. Not 32. We only need 8. Whether that's correct, we will see. We could assemble it. So to test this, we have add let's. Okay, we will see later. If there is a systematic error, we will correct this sooner than later. And welcome everyone new to this channel. So now we only need like let's compact this here a little bit before we commit this. at least, how much do we want to compact that table? Oh, that's probably fine. We need this readable mnemonics. That's a little bit error prone, you all. Maybe we make this here. We would need. How many would we? Are we? Is it not only one? Because this is two. Because okay, YOLO. Then it's not worth it. Kind. Good. So the only other thing, and I don't think Lua allows us, we would need to have here some aliases. A 0 register here, where would be this probably should be here somewhere in this document, but as searching the PDF might be near. So yeah, this is just x to whatever. Okay, interesting. So we could even. So all of them have another name, right? Okay, let's start with 0. So next we would need a table of. I mean, either we have this in the same table and don't care. Let's say 0. I don't believe this will work, unfortunately. Like to reuse this. I'm pretty sure that doesn't work. We could make this a 2-stage lookup. Maybe then we could also print better diagnostics. How do they call this in mnemonics? Or but that's they're all different, right? So 0 RP RA. This how do we best do that now? Okay, let's. Oh, this doesn't. It's pretty lame. I think this worked in Sway. It's pretty lame that you need to manually move that over there. Oh, that is pretty nah. So 0 RA SP stack pointer global pointer thread pointer. That's just human readable pattern names. T0 T1 T2. Actually, we could call this maybe RX or what. Why not? I always, as much as it triggers all those editor people, I always used. Actually, I first used Emacs and then only NVI for console things. It's just that we usually have done like because we need full-blown freaking IDE. Other people use a real IDE. Now I use a real IDE. Like, how do you use a real IDE? Where are we here? 72. Okay, so S0 or FP. So the good thing is we could support both with this encoding, right? Like basically S0 for now. We could like basically other things at the end for readability. It doesn't matter, but so basically FP equals 8. S0 as 1 saved register 0 frame pointer. S0 as 1, so that's 8, right? S0 as 1 function argument return A0 A1 A0 A1 until, okay, so we have A0 until A7 A1 A2. When you delete, it's just a flip. Is it A6? Where are we? A6 should be X16. X16, A6, yes. A7, right? A7. Saved rex 2, S2, S3, S until 11. S. Where are we? What did I say? S3? S2? S2. Advanced movements. S3. S4. S6. Any typos, you all? The good thing is when we did one architecture, the others are relatively similar, so we only need to copy this and change the encodings for PowerPC and stuff. S7, S8, S9, S10, S11, just 11, 27, and then T3. I think we because only duplicate things. Yeah, we could have them all in one table. It also, I mean, okay, there are no duplicates, right? Actually, you know what? Like, let's for now, like if we later need two tables, we will see. Let's for now put them in one table. YOLO. Let's see. Does it still work? Amazing. Let's so now we would next need to assemble some real things. We could actually check the encoding. And if we make this here longs, which I hate this type, as you know. What if I don't know? Long test, long AB, what? Error expected What have I done? For plus token? Are you kidding me? Is there some white space shit or what? Whatever. That is an add. We could actually check that our stuff is correct. So let's use add. And so they add A0, A0, A1. Let's immediately test this. Argument 0, because it's so it's destination and source, A argument 1, argument 0. That is how simple machine CPU code low level things are. If we now assemble that for real and compile to test O, linker output on this. What did I do? Dash OL. Not CO. Compile to. We also don't need this, but YOLO. And object dump that now. We don't have a matching object dump. Clear off. Object dump. Disassemble. Just everything test. Yeah, disassembles like that. This is by default. Like, why is it by default not just using the test section? I don't understand. Also, we need a red. Did it auto red? Where is? There was a red. Okay, let's add return. Why not? Let's emit 2 instance. Let's test more shit. Oops. Let's test red. How hard can it be? We only need to find it here in this table. That will not be easy to find. Although, I mean, it's okay. It's relatively easy to find here. Just instruction encoding somewhere. Why did I earlier search for something else? Yeah, pro tip. Pay an intern to copy and paste all of this in a good PDF viewer. Certainly don't steal it from another open source project like GPL licensed GNU assembler. Maybe you probably could steal it better from the raw source file here of this PDF they generated with whatever docbook or whatnot. Somewhere should be. These are all extended things of. There's encodings. Do they have all extensions on one document? I was already wondering why here are so many other things. So that's all. This is a combined, all ratified. Now I understand. That is also why this is so humongous. Probably here somewhere. Unconditional jump. We need a return. Actually, maybe a return might be a synthesized. So here's encoding variants. Although there are. We have is that all we needed? What do we have here? Immediate. RISC-V. We have UJ. Between S and B, 12-bit immediate integer. So some things, for example, move, like RISC-V doesn't have move. They use add or whatever. I mean, you could use anything with like just add, like source. Oh yeah, right. Like move. Like basically move is add with destination, your destination, and source, your source, and then 0, right? That's a move. Load store memory ordering. Where are I think I scrolled over that already. Additional, unconditional Jump and link instruction uses J type. It's probably jump and link or whatnot. There it is. Where do they have their pseudo instructions? Nah. It should be easier to find, but it is what it is. Red versus it's probably jump and something of that sort. Yeah, irises would be easier findable. Searching for red, how useful could it be? Maybe I shouldn't search for red with space, but that will yield even more. 700 hits. And there I probably skip over that also, but yeah, the longest ironically takes getting the information out of the specification. Pseudocode abstraction. How do they call this? Do they call this pseudo? Here, move. Here is move. Plain unconditional indirect jump are encoded as jump and link with RDX0. Procedure returns in the standard calling convention assembler. Red are encoded as jar with x0, x1 and immediate 0. So jump and link x0, x1. The question is, how is this? We need some form to express that. Okay, let's do the simple thing. Let's first, okay, that is jump and link. Oh, here they have also did. Oh, this is also a bit. For disassembling, like if we wanted to disassemble this nicely, we would. So jump and link. Jump and link register. So what is our basically immediate, right? Like basically, so that is, what did they say? X0, X1. Actually, we have nicer names for that, right? We have that is 0 and RA, making it immediately more readable, right? So that should be, oops. That should be 0. Wait, what did they say? Destination? Destination X0 and source X. What did I say? RA, return address. And then offset 0. Did they say that? Immediate 0. Okay, that is, which one is that? This is with immediate, 12-bit immediate of function 3. Next instruction to implement. Which type is it? It's not that. Is it I? 12-bit immediate RS function 3. I think it's I. So this is any new instruction. It's like we have not. Okay, let's delete what we didn't do. Which did we do? We didn't do any correctly. We wanted add, right? Like the one really we wanted add. Maybe we simply type all of them like this, just for uniformity, readability, and stuff. Even those we would not need to write like this. So what did I say? Type I guess. So we need to correctly encode add and JALR, so 0 thing stuff immediate. Okay, those probably okay. What else? Okay, that. Next. And so then it goes very quickly, right? Like, so basically, and then just like people are saying like it's a crazy, it's like, no, like in 1 month, if I would work full-time 1 month, we would have half a decent code gen, I'm pretty sure. Could even immediate 12 or whatnot. So maybe just EMM for immediate. Immediate. So so we have only RS1. So convert RD RS1 done. Function 3 we have, right? Function 3, yes. So RD RS1. That's 15. Here's the, what we need RS1 here. FN3, that's also correct. RD, so that's of course uniform. That is 12. Oops, sorry, that is 12. Function 3, 15, 12, and 15. Oh, I didn't. Here, because we pre-shifted here already. Actually, you know what? It's slightly annoying to read. I think I rather want that here. Maybe even here then. Then we have the bit position instantly readable. Here's the immediate anyway, so, and so is it 20? Yeah. So because it's fully uniform, we don't have all of those, so immediate. Is that not amazing? Next thing done. Happy to hear that. And that, I mean, it kind of sort of demystifies it also. Like, of course, people at university should do that as some practice thing. But also, it is much easier than, like, if you know some basics, it should be relatively, I mean, famous last word, it should be easy, but of course the complexities and also supporting ELF, extendable link and whatnot format there. And like the surrounding infrastructure is like more work. I mean, probably, ironically, the surrounding infrastructure is probably 80% of the work, like all this core assembly 20%, and then like supporting all the object format and relocation and stuff. But it's not rocket science. It's really, this is really simple stuff, in my opinion. So we only need to find the table here. Pro tip: don't jump around. We only jump around because we want to implement some as proof of concept. What do we have here? Source. What is that here even? Not a fan that they have so many. It performs the same, but additionally, right? Is that the compressed form, or is C dot? Does it mean compressed, right? I guess. Yeah. Must be. This is a compressed listing. I only want this number. All I need is a number that this is encoded with. I'm a little bit shocked that I skipped over that already. I mean, sometimes, I mean, either printing this 5 pages with listing, or you don't need to print it. You can also save, like if you are modern, I mean, or bookmarks. It's also knob instruction, by the way. What do they knob for? Knob is add I x0. Knob is encoded as add DDI. So we basically need some form. I mean, this is easy. This is fully hard coded. But what I mean, red is also fully hard coded. So we need some way to encode those. Maybe second table, not pseudo, whatnot. Not important. Can always rename it. So that would be something of return is equal jump and link register x. I mean, this was okay 0 RA return address comma 0 and knob. I mean, not that we would need knob so much, but knob is, as we find this already, let's write it down, then we don't miss it. Add I x0. I mean, you can do knob in every shape and form, but CPU cores could potentially optimize. Like, basically, add sub, even, hey, super expensive knob, like multiply shit with x. Multiply, if you want a really slow knob, potentially like multiply 0, 0, 0. It's like, yeah. But the only reason to do this is to give the cores, like, not have every program write some other arbitrary sequence of like, it does nothing, so it's probably fine, but give, like, basically have define like Spark and ARM and stuff. Also do that, like, A or x86 variable lengths, like 1 to 15 or 16 probably, 1 to 16 variable lengths of, like, also like possibilities are infinite possibilities of encoding up or so. At immediate, what do we have here? 0, 0, 0, 0, 0, 0, 0. You can also do this with Mool and stuff, but at immediate, I mean, why do they not do 0, 0, all zeros? But I don't know, whatever. Maybe that's more zeros, I don't know. Okay, save, and we actually were looking for jump, and we could even already implement, so that was 0, 0, wait, what? Ah, this is the right one. Basically, we could look up so we could support that already. Look at that, everything implemented here in one session. Just 2 hours and we have half an assembler. We only need to hire an intern to copy and paste all the opcode numbers together. Basically, first, pseudo in let OPC equal pseudo op if, so then we don't need two local. I mean, okay, that basically doesn't hurt. It also doesn't matter. I mean, actually we could fall. I wanted to recursively call it, but actually we could just fall through for okay, the only things we need to solve that. So the only thing is we don't have the arguments. Okay, I think we could recursively call this after all. If OPC, so if, just to have the arguments right, if that is a thing, then init insen again, return tail call turn insen, basically the whole thing, right? Like s unpick code. I leave it here, like in case we later copy and paste it or stuff, then we have, it doesn't hurt to shadow that. Expected in 17 for pseudo. Yeah, let's see. I wouldn't type so much random shit. Oh, what do we want now? Save file, yes, what have I done? Sure, what I've done. Near expected 19, yes, comma, comma. And syntax error near 52. Syntax error near 52. Oh, wait, we're not done here. Let RD, wait, what did syntax error? Why is the syntax error? Here I deleted somehow too much. Wrong. RD also, okay, we overwrite this week then. Okay. I commented this wrong. Too many years of lure. So, y'all not supported. Yes, I know. Let's encode y'all. Basically, we need y'all, and we need, so that's type, what I say, I for immediate, right? Type I. And we need, what was the other? At I. If we wanted not, which we didn't have yet. Global O, attempted to index global 71. What have I done in 71? Didn't update those yet in this rename. Good that we test more code passes. Wait, what have I done now? Hello? Where people use VI, I guess. People struggle to exit their VI. How do you exit Emacs scratch buffer in history? So invalid rec nil for opcode YAL RD. Return. What do we do here? Which is, I hope unpack should work, right? Unpack for variable arc things, or does my unpack magic here not work? The So pseudo is YAL 0 RA. What's going on here? If opcode in pseudo, then tail call emit in with S opcode. Should this not work in, let's debug printf that. Did I not save this enough? Or did I not write return here? Oh, I didn't. I did this wrong. This is totally correct. My assembler is correct. I use this. Look at this. No, it assembles. Amazing. Yeah, certainly next test cases, then you don't have like what random thing doesn't happen. So that's our first encodings here. They're not yet correct because we have not we need where's our, we were just searching for that correct encoding here. Where is it so? Google Drive not driving? Hello, Google Drive. With one job. What's Google doing? Oh, we have 117 drop frames. Just unload it locally, otherwise PDF view on there. Wait, this is not the right one. This one. ASCII doc. So you're saying 5.5. Somehow the new document. People spend so many efforts and then. I don't really mean. Here maybe. Yeah. Thank you. We only need, is it RVI? Okay, RVI. Yeah. Something like that was in the other document, I'm pretty sure, but wherever it is, I don't know. My PDF viewer doesn't find it. So now we need to write encodings. What did we in this example we had add. Add is, I think they grouped this here by, so add is maybe here add. Oh, here. Yeah, we had this the other day. Okay, all zeros. Here we can copy that maybe. Let's see. Oh, that even worked. Because if we paste it like this, we have here all the bits. Look at this beauty. Now we only need an intern to go through this shit and do that for all the things. Jump. Maybe I can teach my kid already. So, YAL. And that of course has less bits. Okay, let's do add I immediately because then we have those done. I mean, we should just copy and paste them all. Actually, what we should do, like Apple's preview can do rectangular selection. Like, I mean, maybe if we do it like this, it could potentially work, or we extract it from some other proper source. Add immediate is here. 0, 0, 0. Add immediate, then we have all that we started, maybe somewhat fully done. And load, wait, that is, why do we have load? Why do we do load word? Do we do load word? Thunderbird is what's, alright, PowerPC. We changed this. All right, we changed this. Okay, let's do that later. Load word. Our load. Okay, we also can do that later. basically this we have done. Although so many are really quick. Also arithmetic and logic ones, it's just 8 times the same thing with add, subtract and stuff, just some high bits different. Maybe I even patch our Lua fork and support that here. How many verses? 3, right? Like 7. 1, 2, 3, 4, 5, 6, 7. That we could write it like this. Initially I didn't like that, but like with such numbers, actually, that would be relatively helpful. I think maybe later, maybe Lua 5.4 supports this. We maybe want to patch that into, or like simply skipping this and parsing numbers for such formatting reasons. Are those at immediate? Probably they are. Okay, so we only need to fill this table. I mean, only. Let's see if this. Did I change it? Did this already? Doesn't look correct. It doesn't look quite correct. We should have add and read. So, I mean, okay, those are quite 0. Okay, fair enough. It's only the add pad. Ah, this changed here. You see, this is the right opcode now. Ah, yeah, this just changed. Yeah. Maybe it's correct. Let's see. Disassemble object dump. It's compressing that. March RISC-V. What do we have here? Even RV. What is encoding? RV60. RV64G. Ah, wait, what did I do here? Object dump, that was so wrong. Here. March RV64G. The difference is no compression. So does it match our implementation? B50553, can you believe? And even B505338067. We successfully assembled our first instructions. Now we only need to fill all the stuff, implement surrounding ELF format object, ELF or other object things. That's the assembler. Linker is another thing with relocations. If we wanted some compatibility for testing, that would be implementing the parser for that stuff. Many of the stuff is of course pointless. Only debug information stuff, only like file name and stuff. Yeah, supporting this, reading symbols, right, symbol types and stuff. So that's a little bit information. As you see, the instructions is simply outright just dumping, converting human readable ASCII text into machine code. That's all what assembler is, right? The difference between assembler and machine code is like assembler is human readable stuff to be assembled. That's why it's called assembler. Assembling that to machine code, the numerical values, the bits and bytes, the ones and zeros. Yeah, of course, before our whole project, we have some design decisions to take how we precisely want to use it. I mean, it's kind of useful. And that's what I mean with massive reduction code size, right? Like implementing no bells and whistles, only the basics. I think to have some, I think you could always make it even tinier and more obfuscated, but I guess we would want to support, I mean, we need to generate some non-directly language generate things like atomics, cache flush fences, read machine specific control registers, and stuff like that. So I guess we probably wanna, although we don't need it, we could implement here quite some compatible stuff just for testing or reusing it. Also a lot of instructions our compiler will probably not generate. That's it for that quick video where I thought I swapped a Power 8 CPU that didn't work. Did some language design thing then here. I hope you enjoyed to learn something. I guess time to commit this, make more work. So the first video we started on some language high level language design things. Today from the opposite side, and from that we should build up of assembling things, generating things, linking things, supporting some surrounding object file formats for easier interchange, and then filling the gap in the middle between the high level language parsing and code generation, and that all in all not a too impossible task as you see here. Now I need to really go have some lunch and do some other work, because actually initially I only wanted to swap Power 8 CPU. That's it then for this video. I'm hungry. Continue the next day. Hope you enjoyed to learn something. Don't forget to subscribe, especially Patreon, and otherwise support it, or just our amazing music on Spotify and iTunes and stuff. What do we have here?
Threads for freedom's sake.